Good day. Welcome back to our 7th lesson on grade 11 graph interpretation with nature of roots. Let's see what this problem is about. In this example, they say that the following sketch shows the graph of this parabola. You can see the equation was not given to us. That is fx, and gx is a straight line graph, and the equation is gx equal to x plus 5. PQ is a vertical line. They refer to this PQ, the vertical line. It's a vertical line segment between G and F, and the G and F refers to the two functions F and G, such that the x of A is less than the x of B is less than the x of B. Plain common language, it means that this PQ line must be between the 2 points of intersection. So it must be somewhere here. That is what they are telling us by giving us that. So as you can see, they ask us now to find the values of A, B, and C. And that is the A, B, and C from this parabola that they want us to find. Now, when we look at the drawing, you will notice that this x-intercept was given to us at -1. This x-intercept is not given to us, but it is the same as the x-intercept of the straight line. So we can easily find this point by using the equation of the straight line, and that will give us this x-intercept. And then we can also use the straight line to find the y-intercept, which is the y-intercept of the straight line, but also the y-intercept of the parabola. So let's start off by finding the x and y-intercept of the straight line. So I'm going to say that for x-intercept of, and I'm going to say of g, so that we know we are working with function g, and that is where we substitute y with 0. And that means now that x plus 5 will be equal to 0. So therefore, x will be equal to -5. I'm going to put that on our drawing. And that -5 is this x-intercept right here on our graph. The -5. Now for the y-intercept of G, so I'm going to find the y-intercept of G. So that is where we substitute x with 0. So that means that y will be equal to 5. And that 5, I'm going to put right here at B. That is the y-intercept. We are now ready to start with the equation of the parabola, and you hopefully still remember the form that we use when we have the x-intercepts of a parabola. And that form is y equal to a x minus x1, x minus x2. And that x1, x2 represents the two x-intercepts. So let's just substitute that first. So we're going to say it is x plus 5 and x plus 1. Because of the minus, and those two x-intercepts were both negative. So now we're going to substitute point B, which is the y-intercept, which is the point 0,5, into this equation, and that will help us to find A. So we're going to say that y is 5, a we're going to leave because that's what we want to find, and then we say it is 0 plus 5 and 0 plus 1 because that is what we substitute x with. And now you can see that we will get that 5 is equal to, and if we multiply that, we get 5a, so that means that a is equal to 1. So that means we can now find this equation. So we can now say that y is equal to 1 times by x plus 5 times with x plus 1. And if we solve that, we will get x squared plus 6x plus 5. Now, we're not going to leave the answer like that. Please remember, they ask us to find A, B, and C. So it's important that you finally just write that down. So we can now say that from this equation that A will be equal to 1, B will be equal to 6, and C will be equal to 5. And you will see that is exactly what they ask us to get, and that is what we have here. That A is 1, B is 6, and C is 5. Let's now look at the next question. In this one, they ask us to determine the coordinates of t, and they say that represents the turning point. Now it is that turning point of t, the parabola's turning point. Now, to find that turning point, we're going to find the axis of symmetry first. So our equation of this parabola is y equal to x squared plus 6x plus 5. So I'm going to find the axis of symmetry, and that is x equal to minus b over 2a. And when we substitute b and a, and our b, as you remember, was equal to 6, and our a is equal to 1. So we will have minus 6 over 2 times 1. So that means that our x will be negative 3. So that is the axis of symmetry. Now we still need to find the turning point. So that means we must substitute this x equal to minus 3 into fx. So we're going to work out the f of minus 3, and we substitute this minus 3 into x and that x. So we will get minus 3 squared plus 6 times minus 3 plus 5. And that will give us the y value of our turning point. And I hope you agree that this will give us 9 minus 18, which is negative 9, plus 5, which will leave us with minus 4. So that means our turning point will be x equal to minus 3 and y equal to negative 4. Right, so let's look at the next question. In this question, they say that we must determine the maximum length of PQ. That is that line PQ. They want us to find the maximum length of that line. Now, what does that mean? It's important that you first understand what the question is about. This line PQ, we want to know what is the maximum length. So you can see that this line can be anywhere between these 2 points of intersection. If I draw it here, you can see it's much shorter, and it's getting longer and longer, and then it's getting shorter and shorter again. And we want to know what is the maximum length. Now, whenever they ask you for maximum length, you take the top function, which in this case is the straight line, and you subtract the bottom one, which is the parabola. So we're going to start off by saying that PQ will be gx minus fx. Important, not fx minus gx, but gx minus fx, for the reason that P is on the straight line, and it's always the top one minus the bottom one. And now we're just going to substitute these two functions because we've got both equations. The straight line is x plus 5, subtract, and please remember to subtract in brackets here. That is x squared plus 6x plus 5. And now we just simplify this, and we will get x plus 5 minus x squared minus 6x minus 5. And that will leave us with, when I simplify this, with minus x squared. You will notice that the positive 5 and the negative 5 will subtract to 0. And then you will see that this x minus 6x will leave us with minus 5x. So this PQ now represents this maximum length. Now, to find the maximum length, we're going to complete the square on this quadratic expression. So we're going to say that PQ is equal to, and you remember when we complete the square, we take out whatever is with x squared. In this case, it's a minus 1. And we are now left with x squared plus 5x. So we took out the negative now, and now we need to change this binomial into a trinomial, which is a perfect square. And to do that, we take this coefficient of x, we divide it by 2, and we square the answer. So we're going to, if I just write it down separately, I'm going to say it's the 5 divided by 2, and I'm going to square that. And I'm going to add this and then subtract it so that it stays the same. So we can say that PQ is equal to negative, and then we say x squared plus 5x plus 5 over 2 squared minus 5 over 2 squared. And it means it still have the same value. These first 3 terms will now give us a complete square. So we can say that PQ is equal to, and be careful just with your brackets now, and that minus 5 over 2 squared will stay. And now we're going to factorize this trinomial, which is fairly easy to do. So because we get an x times an x, and that 5 over 2 squared is 5 over 2, 5 over 2, and both must be positive because our answer for the middle term is positive. So we can write this now as a square. So we can say it is x plus 5 over 2 squared minus 5 over 2 in brackets squared. Now we're going to remove the outside brackets, and that will give us then negative x plus 5 over 2 squared. This negative times with this negative will give us a positive. So I will get plus, and I'm going to solve that bracket at the same time, and that will be 25 over 4. Now we are ready just for our final answer. So as you can see now, we completed the square plus this. Now from functions, you will remember whenever the parabola is in this form, we call it the APQ form, that is the axis of symmetry of the parabola, and that gives us the turning point. That means the maximum or a minimum. In this case, it's a sad face, so that will be a maximum. They ask us for this maximum length, and now we can just say that the maximum length of PQ will be equal to 25 over 4, and we can also write it as a decimal issue if you wish, and that is 6,25 units. And that, very important, and I'm sure it makes sense. Let's now look at number 4. In question 4, they ask us that if the f of x minus t, you will see that x minus t is in the bracket, equal to 0, has one positive and one negative root, determine the possible values of t. Now, if you look at this graph, you will notice that this is the one x-intercept, and that is the other x-intercepts. And like we said before, these x-intercepts are also called roots. So those are the x-intercepts, and both of them are negative. We want one positive and one negative. So that means we need to move this parabola, we need to shift it so that this x-intercept at -1 is just on the positive side, just past 0. So that means we must shift this function 1 unit to the right. But if we shift only 1, it will be at 0. We must shift it more than 1. So that, as you remember, this notation refers to a horizontal shift. So we can now say that we're going to shift this graph 1 unit to the right. So that means 1 must be less than t, but we can't shift it more than 5. You will remember we calculated this x-intercept earlier as -5. So if we move this more than 5 units, then this x-intercept is also positive. We want to move it more than 1, but less than 5. So that means this is less than 5. And that will be our solution for t. In question 5, they ask us for which values of k will fx equal to k. And you will notice there's more than one sub-question. So in this first one of number 5, they say fx is equal to k, and the roots must be different, 2 distinct roots. In the second part, the roots must be non-real. So let's just look at this one. So fx is equal to k, that is the parabola that was given to us. And they now said to us it must be equal to k. Now for 2 distinct roots, you will remember we draw the line, this horizontal line, above the turning point. So we're going to draw the horizontal line above the turning point, somewhere there. You will remember from our previous calculations where we did the turning point, that this turning point was at y equal to -4, that y value. So we must draw this horizontal line, and this line is y equal to k. We must draw it above the turning point. Our answer for this one is, therefore, k greater than -4. And please make sure that you understand why. First of all, the roots are different, or 2 distinct roots. So that means we must draw the horizontal line above the turning point, and the turning point is at -4. We must draw it above, not equal to, only above. Then there will be 2 distinct roots. So therefore, k greater than -4. In the second one, they say to us the roots are non-real. Now for non-real roots, we draw the horizontal line below the turning point. So let's do that. So I'm going to draw the horizontal line below this turning point, and that y value is at -4, and this is the line y equal to k. So we can now just write down the answer for this one. So we can say that k, in this case, must be less than -4. Please take note that if we draw it above the turning point, it is greater than -4. If we draw the line below the turning point for non-real roots, then it means it will be less than -4, and therefore the k must be less than -4. Let's now look at the next question. In this third part of question 5, they ask us to find k if the 2 roots are negative. Both roots must be negative real roots. you'll remember it was given to us that fx is equal to k. Now, the moment that you see that fx is equal to k, this k represents a horizontal line. But now we must be careful where to draw this line. In the previous questions, when they told us the roots must be non-real, then we must draw it below the turning point. If they say the roots must be real, we draw it at the turning point. And if they say the roots must be unequal to unequal roots, we draw it above the turning point. But now it's about the nature of these roots. So let's just now see where we're going to draw these lines. First of all, if I draw a horizontal line here, y equal to k. So let me just draw it there. You will notice that this line intersects the parabola twice, but both those points of intersection are negative, because that is 0 and it's on the left-hand side of 0. So that means both these roots are negative. If I draw the line at that y-intercept, so this is now the line y equal to k, this is also a line y equal to k, you will notice that this root is negative and that root is 0. If I draw the line above that y-intercept, you will then notice that this root is negative and that one is positive. So if I draw it above the y-intercept of 5, or y equal to 5, we will have one positive, one negative. If I draw the line at this y-intercept of 5, one root will be 0 and one will be negative. If I draw the line below this 5, the y-intercept of 5, then the roots will both be negative. That means that k must be less than 5, but it's very important that k must be also greater than -4. So that means that our final answer will be k greater than -4, but less than 5. Thank you.